Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children. My screen is visible, right?
Yes, ma'am.
Yes,
Okay.
ma'am.
All right, children. Yesterday, we discussed the answers to the questions from 1 to 7. We said we'll do 8A and B today. So let's see 8A. Find K if 9x squared minus 6kx plus 2 is equal to 0 has real roots. So we need to find the value of K. See here, K. We need to find the value of K if the given quadratic equation has real roots. Now, these are three things we know. The value of the discriminant being less than 0, the value of the discriminant being equal to 0, the value of the discriminant being greater than 0. And we know that when D is less than 0, the quadratic equation has unreal roots or imaginary roots. Imaginary roots. See, how can we classify the values D can take? D can take any value less than 0, that is negative. D can take any value greater than 0, positive, or D can be equal to 0. So this covers all the real values. The value of D on the number line, let's just take a number line, 0, negative numbers, positive, all right? So we have all the real values on the number line. That is both rational and irrational. Now, D can be equal to 0. The value of D can be equal to 0. The value of D can be negative, that is less than 0. Or the value of D can be greater than 0, that is positive. Let me do it again for you. See here, slowly, see here, number line, 0, negative numbers, positive numbers. So this is the entire collection of real numbers. This is the entire collection of real numbers. The value being equal to 0, value being negative, value being positive. So this contains all the real numbers. All the real numbers. We know every real number has a unique position on the number line. Every real number has a unique position on the number line. So number line, 0, all negative values, positive values. So D can be the value of D can be equal to 0. When the value of D is equal to 0, that means the given quadratic equation has equal roots. Equal roots meaning real roots, real equal roots. See, if roots exist, that means they are real. If roots exist, that means they are real roots. When we say that the quadratic equation has equal roots means the roots are real. That's why they are equal. Real equal roots. The value of D can be positive. The value of D can be positive. When D is positive, the quadratic equation has unequal roots. D is equal to 0, equal roots. D is positive, unequal roots. And when D is negative, when the value of D is negative, that means the given quadratic equation has no real roots. No real roots. So let's write it here. When the value of D is less than 0. When the value of D is less than 0, that is when the value of D is negative. When the value of D is negative, the quadratic equation has no real roots. Let me write it again. When the value of D, when the value of the discriminant is less than 0, that means when the value of the discriminant is negative. How do you find D? D is found using B square minus 4AC. How do we find D? Using B square minus 4AC. Now you find the value of D using B square minus 4AC for some particular quadratic equation. And you get the answer as minus 5. D is equal to minus 5. D is negative. D is minus 5. D is negative. That is, its value is less than 0. Discriminant is negative. That means the discriminant, the value of the discriminant is less than 0. It's less than 0. It is negative. Both are the same. Negative meaning less than 0. Both are the same. The value of the discriminant is less than 0. It's negative. What does this indicate? This indicates that the given quadratic equation has no real roots. Its roots are imaginary. Its roots are imaginary. Real roots don't exist. Please understand, when the value of the discriminant is less than 0, that is when the value of the discriminant is negative. So something like D is equal to minus 11 by 2. It's negative. That means the given quadratic equation has no real roots. Its roots are imaginary. It does not have real roots. Real roots meaning the roots are not rational or irrational. Real roots meaning what are real numbers? The collection of all rational and irrational numbers are real numbers. It does not have real roots meaning the roots are not rational or irrational. They are unreal. They are imaginary. It does not have real roots, meaning the roots are not rational or irrational. Because they're not real. It's not rational, it's not irrational. They're not real. They're unreal. They're imaginary. That's about the roots of the quadratic equation when the value of D is less than 0. When the value of D is less than 0 or when D is negative, the given quadratic equation has no real roots. It has no real roots. The roots are imaginary. Next, when the value of D is equal to 0, when the value of the discriminant is equal to 0, when D is equal to 0, the given quadratic equation has real roots and the roots are equal. Both are the same, like 5, 5. Both are same. When the value of the discriminant is equal to 0, when the value of the discriminant is equal to 0, the given quadratic equation has real roots. It has real roots. And the real roots are equal. Both are equal roots. That means it has only one root. But when we say 2, we say 2 equal roots. It has one root or 2 equal roots. The roots are real. The roots are real and they're equal. They're real and equal. When the value of D is greater than 0, that is when D is positive. So you get D is equal to 225, 220, something like this. Some positive value. It can be a fraction. When the value of the discriminant is positive, we're only talking about the discriminant B square minus 4AC, this one. When you find this B square minus 4AC, if it is positive, if it's positive also, it has real roots. The given quadratic equation has real roots, but the roots are real and unequal. Unequal meaning 2 different roots, like 3 and 5 are the roots. Two different roots it will have, or minus 3 and minus 7 by 5, whatever. 2 different roots. 2 roots, 2 different roots. So D less than 0. That is D is negative. The value of D is the value of B square minus 4AC. It's negative. That means the quadratic equation has no real roots. No real roots. D is equal to 0. Is equal to 0. That means the quadratic equation has equal roots. Real equal roots. Real and equal roots. When D is greater than 0 or positive, when it is positive, the quadratic equation has real unequal roots. Two different roots, unequal roots. So which are the cases where the quadratic equation has real roots? When D is equal to 0, it has real roots. When D is greater than 0, also it has real roots. The roots are real when D is equal to 0 or when D is greater than 0. The roots are real. See, you can see real roots, real equal roots, real unequal roots. So you can see equal roots when D is equal to 0 or when D is greater than 0. So the condition for real roots is D being greater than or equal to 0, combining both because greater than equal to. Greater than equal to. In both the cases, the roots are real. So the condition for real roots is D greater than or equal to 0. This is the condition for real roots. Remember that. The condition for equal roots is D is equal to 0. The condition for unequal roots, D greater than 0, because unequal is only when, D is greater than 0. You can see here, unequal is only when D is greater than 0. Equal is only when D is equal to 0. But real, where is it real? In both the cases, when D is greater than or equal to 0, it cannot be greater than and equal to 0 because it cannot be greater and equal to 0. So greater than or. Use or, not and. When D is greater than 0 or when D is equal to 0, in both the cases, D greater than 0 or when D is equal to 0, the roots are real. The roots are real. Are we all looking at the screen, children? Did you see all the annotations?
Yes, ma'am.
Now tell me, children, tell me, when D is less than 0, that means positive, negative, or what is it? When D is less than 0, it means
Negative.
D is
Negative.
negative.
Negative, not real.
Negative. So the roots are, the quadratic equation has
Unreal. Unreal.
no real roots.
Not
Unreal.
real.
Not real roots. Imaginary roots. Whatever has imaginary roots. Imaginary roots. That means no real roots. Okay. What's the next one? D.
D
Equal
is equal
to
to
zero.
0.
D is equal to 0. D is equal to 0 means when the value of D is equal to 0, the quadratic equation has
Real equal roots.
real and equal roots. Real and equal roots. Correct. Real and equal roots. That means both. It has only one root. It actually has only one root. But when we say 2, it has two equal roots. Then when D is greater than 0, that means
real and unequal roots.
Yeah, D greater than 0 meaning D is
Positive.
positive. When D is positive, the quadratic equation has
Real and unequal roots.
Real unequal roots. Real unequal roots. So what is the condition for equal roots? What is the condition?
D should be equal to 0.
D equal to 0 is the condition for equal roots. What's the condition for unequal roots?
D should be greater than 0, positive.
D greater than 0 is the condition for unequal roots. What's the condition for equal roots? What is the condition for equal roots?
D should be equal to 0.
Yeah, repeat. Yes, repeat. No, because you will be expecting the third question to be different and you will say greater than or equal to 0, which is why I repeated the question. What is the condition for equal roots?
D is equal to
D
0.
should be equal to 0.
What's the condition for unequal roots?
D greater than 0.
D greater than 0. But whether it is equal or unequal, the roots are real, right? So what is the condition for real roots?
D
D
should be
greater than
or
or
equal
equal to
Greater or
0.
equal to 0.
Greater than or equal to 0. D greater than or equal to 0 is the condition for real roots, because real roots meaning we have two cases when the roots can be real. D greater than 0, roots are real. D equal to 0, also roots are real. So combining, putting them together, D greater than or equal to 0 is a condition for real roots. Equal roots, D is equal to 0. Unequal roots, D greater than 0. No real roots, D less than 0. But that's been deleted from the syllabus for you. So we are not going into that. D less than 0. You can just remember that as a condition, but we don't have problems based on them. Okay, so now let's read the question again. Find K. See, normally, how does a quadratic equation look like? Something like 3x squared minus 5x plus 11 is equal to 0. So you can see x squared and a number before that, coefficient. You can see x and a number before that, and the constant. But here, what do you see? You see x squared and a number 9 before that. You see x. But then 6k, oh, this should be a number entirely, 6k. So it can be like 6 into 1 or 6 into 2. K should take some number here. K should take some number there. Because we see x, its coefficient is 6k. K, what's the value of k? That is what you have to find. And 2 is a constant. We need to find the value of k. The question is find k if 9x squared minus 6kx. 6k, the coefficient of x is minus 6k, to be precise, minus 6k. So that k there in minus 6k. We need to find the value of this k if the given quadratic equation has real roots. So the condition for real roots is discriminant being greater than or equal to 0. We need to write the condition first. Write the condition first. Write the condition. The condition is discriminant greater than or equal to 0 for real roots. That means b square minus 4ac is greater than or equal to 0. So what is the value of b, children? From the quadratic equation, what's the value of b?
Minus 6k.
Minus 6k. Minus 6k the whole square minus 4 into a. What's the value of a?
9 into 2.
9 into
2.
2. Greater than or equal to 0. Are we all following, children? Class?
Yes, ma'am.
Okay. Now work this. What is minus 6k the whole square?
36k squared.
Minus
72.
So 36k square is greater than or equal to 72. K square is greater than or equal to 72 by 36. K square is greater than or equal to 2. Transpose, so you get plus 72. Then 36 comes for division. So k square is greater than or equal to 2. K square is greater than or equal to 2. We need to find the value of k, not k square. We need to find the value of k. So remember this. There are many rules, children. I'm not again introducing the rules because most of it is deleted from your syllabus. So just remember this. This alone is important for you. When k square is greater than or equal to 2, k will be greater than or equal to the positive square root of 2. Because you know, see, how do you work this? When we have k square is equal to 25, we say k is equal to square root of 25 plus or minus square root of 25. K k is equal to plus or minus square root of 25. But when you have an inequality, inequality meaning we have the greater than symbol, right? We have the greater than sign. So see now when it's square root, we say plus or minus square root of 25. The positive and the negative value, plus or minus square root of 25. So here it's going to be plus or minus root 2. K is equal to k plus or minus root 2 you will get. So use the same inequality for the positive square root and reverse the inequality and write the negative square root, negative minus root 2. See, like we say k square is equal to 36. K is equal to plus or minus square root of 36. K is equal to plus 6 or minus 6. In the same way, k square is greater than or equal to 2. So k will be equal, it'll be plus or minus root 2. K square is greater than or equal to 2. So for k, it will be plus root 2 minus root 2. Take plus root 2 with the same inequality. And for minus root 2, reverse the inequality. So we say k will be greater than or equal to root 2 or k will be less than or equal to minus root 2. Let me just give you some more examples. Now supposing we have k square is less than or equal to 100. Supposing. So we know it's plus or minus k will be plus or minus 10. So what you have to do is k, use the same inequality, write the positive square root. Right, use the reverse the inequality and write the negative square root. K square 100. So k plus or minus 10. So it will be plus 10 minus 10. For the same, use the same inequality, less than or equal to, for the positive value. Reverse the inequality for the negative value. Remember like this, children. That's it. So here, what did we get? I forgot. Okay, I think k square is greater than or equal to 2. Yeah, k square is greater than or equal to 2. So k greater than or equal to positive plus square root of 2 or k less than or equal to minus. That means for all, so there are infinitely many values for k. The values of k is not confined. K can take so many values so that the equation will have real roots. That means for all values of k greater than or equal to root 2, children. Root 2 is approximately what? 1.414, right? Let's just take 1.4. 1.4. Okay, we'll say 1.4. So k greater than or equal to root 2. Root 2. Here we are. Root 2. Root 2 meaning 1.414 approximately. So 1.4 we'll say. So k greater than 1.4, greater than or equal to 1.4. So for all values greater than or equal to 1.4, sorry, k can take any value. K can take any value greater than or equal to 1.4. Imagine values greater than 1.4, 1.5, 1.6, 2, 3, 4, 5, 10, 11, 100, 1,000, 1 lakh, any value. For all those values of k, the quadratic equation will have real roots. Similarly, less than minus root 2. So less than minus 1.4. Less than minus 1.4. Less than minus 1.4. So like k less than or equal to minus 1.4. So values less than minus 1.4, 1.5, 2, minus 2, minus 3, minus 4, minus 5. These values are less than minus 1.4. So for the values between root 2 and minus root 2, it will have unreal roots. Represented here. Let me just see. Yeah, children, you can see it here. You can see it here. You can see here, I've indicated using arrows. See this one here. When the values go like this, these are values less than, see, look at this first. Let me give you some time to think. We get this same inequality, positive square root. Reverse the inequality. Reverse the inequality, negative square root. Please watch this one and this one, this one and this one. Same inequality, positive square root. Negative square root, reverse the inequality. That's one thing you'll have to remember. Your answer ends there. See, I'm just telling you what the answer means. Your answer ends there. What are the find k? K greater than or equal to root 2, k less than or equal to minus root 2. Finish. You have answered the question. I've just approximately shown minus root 2 and plus root 2 on the number line. Greater than root 2, meaning all these values are greater than root 2. Less than minus root 2. Less than minus root 2, meaning all these values are less than minus root 2. So for all these values, and these values, the given quadratic equation will have real roots. So for the values between minus root 2 and root 2, for the values between minus root 2 and root 2, the quadratic equation will have unreal roots. Because roots can be only of two types, right? Real roots, unreal roots. Either the roots are real or they're unreal. So when k takes any of these values or these values, real roots. Between minus root 2 and plus root 2, for any of these values, it will have unreal roots.
Ma'am,
Yes?
can you explain again why is it unreal between minus root 2 and plus root 2?
Okay, sure. So roots can be only of two types, right? If the roots are, the roots can either be real or if they are not real, they are imaginary. Imaginary meaning unreal. Correct?
Yes,
Roots are either real or unreal. Now, when k, what are the values of k greater than root 2? Greater than root 2. Root 2 somewhere here, no, 1.4 somewhere here, between 1 and 2. So I've marked root 2 here. I've marked root 2 here, between 1 and 2, because it's 1.4. K greater than root 2. Greater than or equal to. So greater than root 2 meaning this direction. All these values are greater than root 2. Is that understood? When you take any value in this direction, it will be greater than root 2. Any value of k in this direction, that is less than minus root 2. Minus root 2 is out here. Minus root 2 is minus 1.414 somewhere here. Minus 1.414 somewhere here. Less than k less than minus 1.414. So less than meaning this direction. All these values. Minus 6 is less than minus 1.414. K can be root 2. K can be minus root 2. So k can be equal to root 2. K can be equal to minus root 2 or less than minus root 2 or greater than root 2. For all these values of k, the quadratic equation will have real roots. So what is not included in the number line? See, root 2 and this way it's included. Root 2 and this way it's included. So this is not included, right? So that range, it will have unreal roots, is what I meant.
Okay, ma'am, got it. Thank you.
Yeah. From minus root 2 in this direction, real roots. From plus root 2 in this direction, real roots. So this one is not included. This one is not included. That means when it takes any values in this range, it will have unreal roots. I think we can check it out. No, let me check. Let me just check. Now, let's just pick some value between the meaning in this range, children. Let's check. Let's just take a value in this range. Tell me. 0. Can I take 0? Can I take 0? Okay.
Okay, ma'am.
Now, yeah. So when k is 0, let's see what happens. So the equation becomes 9x square minus when k is 0. K is 0. So 6 into 0 into x. So it is 0x. Correct? When k is 0, children,
Yes,
plus 2 is equal to 0. Now let's find that. And we know, how do we know that the equation will have unreal roots? The value of the discriminant will be less than 0. The value of the discriminant will be negative. The value of the discriminant will be negative. So let's find the value of d here. Let's find the value of d. B square. B square is 0. A square minus 4ac. 4 into a into c. So d is equal to minus 72. See here. Discriminant is negative. Discriminant is negative. Unreal roots. Supposing we take k as 1. Supposing we take k is equal to 1. K is equal to 1. Okay, so it will be 9x square. K is 1. So 6 into 1 is 6. Minus 6x. When k is 1, children. When k is 1. So 9x square minus 6x plus 2 is equal to 0. So let's find the value of d. B square. B square. Minus 4ac. 4 into a into c. So it will be 36 minus 72. So again, negative. It's negative. For any value of k in this range between minus root 2 and plus root 2, the quadratic equation will have unreal roots. For all other values of k, it will have real roots. All right, children. Remember the conditions. What's the condition for how do we find the discriminant, children? How do we find the discriminant?
B square minus 4ac.
B square minus 4ac. D is equal to
Root of b square minus 4ac.
Oh, that is root d. Root d is root of b square minus 4ac. I'm asking d. D is equal to b square minus 4ac. D is b square minus 4ac. Okay. Now, what if the value of d is negative? What if the value of d is negative? What will you conclude if the value of d is negative? No roots. The given quadratic equation has no real roots. No roots or no real roots. Imaginary roots. What if the value of d is equal to 0? What will you conclude?
2 equal roots.
2 equal roots. One,
Equal roots.
yeah, 1 root or 2 equal roots. If d is equal to 0, the quadratic equation has real roots and real equal roots. What if the value of d is greater than 0 or positive?
As unequal roots.
Unequal roots.
Unequal roots. Real and unequal roots. Real unequal roots. So what is the condition for equal roots? What is the condition for equal roots? Class, what's the condition for equal roots?
D is equal to 0.
What's the condition for unequal roots?
D is
Greater
lower than
than
0.
What's the condition for real roots?
D is greater or equal to 0.
Greater than or equal to 0.
Yeah. Next one, children. Two trains leave a railway station at the same time. Two trains leave a railway station at the same time. The first train travels due west and the second due north. So we know that the directions north and west are perpendicular to each other. North, west. Okay, so one train travels in this direction, the other one in this direction. The first one is due west. The first one goes in this direction. The second one in this direction. The first train, that is this train, the first train travels 35 kilometers per hour faster than the second train. This is the first train. This is the second train. The first train travels faster. So if this is x kilometer, if this one travels at x kilometer per hour, this one travels at x plus 35. Because this is the second train. The first train is, sorry, I'm confusing you. North, west. The first train travels due west. This is the first train. And this is the second train which travels due north. The first train travels, this is the first train, it travels 35 kilometers per hour faster. The first one is faster. So if the speed of the second train is x kilometer per hour, the speed of the first train is x plus 35 kilometer per hour. Because the first one is 35 kilometers per hour faster than the second. So if the speed of the second one is x, the speed of the first one is x plus 35. If after 2 hours, so you can see the time factor there. We already have the speed factor, x kilometer per hour and x plus 35 kilometer per hour. Now time. If after 2 hours, that means both the trains travel for 2 hours. Both of them, they leave the railway station at the same time. See that. They leave the railway station at the same time. So now both the trains in their own directions have traveled for 2 hours. Remember that in mathematics, line segments can only represent distance and not speed. Now you cannot say let this length be x plus 35. Let this length be x. Because x and x plus 35 are speeds. And line segments can represent distance, not time, not speed. The three quantities are speed, distance, and time. A line segment cannot represent speed. A line segment cannot represent time. A line segment can only represent distance. So now from supposing you want to mark off 2 points on this in this direction and you want to give it some expression. That expression should be about distance and not speed or time. If after 2 hours they are 130 kilometers apart, after 2 hours the two trains are 130 kilometers apart. So again in maths, the distance between 2 points or the distance between two things is a straight line segment connecting them. So let's say that the first train after 2 hours is at this point. The second train after 2 hours is at this point. This is 130 kilometers. Why is this 130? Because the distance between them is 130 does not mean this distance. It's not like come like this and then go like this, not this distance. Distance is the line segment connecting the 2 points. Distance is the line segment connecting the 2 points. Distance is the line segment connecting the 2 points. So say this is the position of the first train at the end of 2 hours. And this is the position of the second train at the end of 2 hours. This distance between them is 130. The distance between the two trains. See, the train has some length, but you cannot only this point represents the train here because we do not know the length of the trains. So here this dot represents one train. This dot represents the other train. And the distance when you connect these 2 points, that is the distance between the 2 trains at the end of 2 hours. So let the speed of the second train be x km per hour. Let the speed of the first train be x plus 35 km per hour. That is the assumption. Next, so time, I'm sorry, speed is already there, x and x plus 35. Next is time. The 2 trains, they start at the same time and both of them travel for 2 hours. So from here, the first train, say from here, travels for 2 hours and reaches this position. The second train, again, they start from they leave the same railway station at the same time. So the second train, say it starts here and goes in this direction and reaches this place after 2 hours. At the end of 2 hours, the distance, line segments represent distance. So the distance between them at the end of 2 hours is 130 kilometers. So this is the first train, this is the second train. The distance between them at the end of 2 hours is 130 kilometers. So this line segment is equal to 130 kilometers, or this line segment represents 130 kilometers. Now this should represent the distance covered by the first train in 2 hours. And this one is the distance covered by the second train in 2 hours. And how do we find distance? Speed into time, speed into time. Speed of the first train into time. This is the distance, 2x plus 70 kilometers. Speed into time is distance. Speed of the first train into time. This is the distance, so many kilometers. So this is 2x plus 70. Or you can write 2 into x plus 35 also. The second train, for the second train, this one is the distance, speed into time. 2x kilometers, 2x. And how do we connect? Since the directions are perpendicular to each other, these 3 sides form the sides of a right triangle. And the equation is by using Pythagoras theorem. So construct the equation using Pythagoras theorem and solve for x. So you can see the assumption. Let the speed of the second train be x kilometers per hour. Then the speed of the first train is x plus 35 kilometers per hour. I've taken 2 points A and B. You can see there I've taken 2 points A and B. OB is the distance covered by the first train in 2 hours. OA is the distance covered by the second train in 2 hours. And you can see that they're calculated using the formula speed into time. I cannot write or annotate when I zoom in. So you can see here assume the speeds, then find the distance OB, distance OA. Then apply it in the, just a minute, children. Yeah, children. So you can see we found the distance OB and distance OA. And then Pythagoras theorem to construct the equation, solve the equation and find the value of x and hence the speeds of the two trains. Isn't it simple, children?
Yes, ma'am.
Yes, ma'am.
Easy to understand or no? We'll do it again. If you're finding it difficult, we'll do it again. It's not at all difficult. It's just about reading the question clearly, carefully, clearly, so that we understand every information provided in the question. Word problems are all about understanding the information given in the question. And of course, you need to practice. You have to practice. It's not that if you understand the question, you don't have to work at all. You can just do it like that. No, you have to practice. But again, to understand clearly, you need to read the question clearly. So speed, distance, time. Assume the speeds. Time is 2 hours. So using the formula speed into time, find the relevant distances. North and west perpendicular to each other. And distance, that 130 kilometers. B and A are the positions of the two trains. So that line segment AB is 130 kilometers. The distance between the two trains at the end of 2 hours is AB, 130 kilometers. Okay. So Pythagoras theorem will help you to find the value of x. X is equal to 25. So the speed of the second train is 25 kilometers per hour. And the first train is 25 plus 35, 60 kilometers per hour. Please read the steps, children. I'll wait for 3 minutes. Please read through the answer. Is it fine, children? Any questions?
No, ma'am.
No, ma'am.
Okay. Have you completed this one, children? You were supposed to finish this. The time taken by a person to. Yes, very good. The time taken by a person to cover 150 kilometers was 2.5 hours, meaning 5 by 2 hours, more than the time taken in the return journey. Let's read that again. The time taken by a person to cover 150 kilometers was 2.5 hours more than the time taken in the return journey. So that is, there is something like onward journey and return journey. You go to a place and you return from there. A to B, B to A. A to B is onward journey. B to A is the return journey. When you are at A and from A you want to go to this place B, that's the onward journey, A to B. From B, when you return to A, that's a return journey. So there's a person who's covering a distance of 150 kilometers and he says he takes 2.5 hours more than the time taken in the return journey. So that means it takes more time, 2.5 hours more for the onward journey. Return journey, 2.5 hours less when compared to the onward journey. If he returned, so obviously return journey he is taking less time. He takes 2.5 hours less for the return journey. That means the speed is more there because the distance is the same, no? Distance is 150 kilometers. If onward is taking some time, return also should take the same time. That is if the speed is the same. But he says, 1 second children, sorry. Sorry children, yeah. So if the person travels in the same speed for both the onward and return journey, then the time taken will be the same because distance is 150. If it is the same speed for onward and return, same time he will take. But how he takes less time for the return journey because he is increased his speed. Return journey is increased his speed. He wants to go back faster. So he increases his speed. So he takes less time, 2.5 hours less. Onward journey, his speed is less, so he takes more time. Onward journey, his speed is less. He takes more time. Return journey, his speed is more, so he takes less time. Did I exchange the words? Onward journey, less speed, more time. Return journey, more speed, so less time. If we return at a speed of 10 kilometers per hour more than the speed of going is onward journey, what was the speed per hour in each direction? So let us call it the this is for those who did not try or did not understand the question. So we'll say onward journey, onward and return. Okay, onward and return. I'll show the answer. Don't write all this. Onward and return. Okay. So speed onward, if it is x kilometers per hour, return is more. Return is more, 10 kilometers per hour more. Okay. The distance is the same. Onward distance 150 kilometers. Return distance 150 kilometers. So then what is this 2.5? It's the difference in time taken. Difference in time taken is 2.5 hours. See, we've used all that is given in the question. See here, 150 kilometers is the distance. Onward distance 150, return distance 150. Onward distance 150, return distance 150. 10 kilometers per hour more. So onward speed is x, return speed is 10 kilometers per hour more. So x plus 10. Both the ways distance is 150. Speed onward x, return x plus 10. 2.5. Onward, you know, this for this journey onward, he takes 2.5 hours more. For this journey, for this return journey, he takes 2.5 hours less. So where does he take more time for the onward journey? The difference in time taken is 2.5. Like onward journey, if he took 12.5 hours, onward journey, if he took 12.5 hours, return journey, he takes only 10 hours. If onward journey, he took 12.5 hours. Return journey, he took only 10 hours. That's why the difference in time taken is 2.5 hours. Difference in time taken is 2.5 hours. That's how you should understand that information. 2.5 hours more. The difference in time taken, that is time taken for the onward journey minus the time taken for the return journey, is equal to 5 by 2. 2.5 or 5 by 2. That's what he's telling there. He takes 2.5 hours more than the. You please read it. Even if I do it, many times, only when you receive it correctly, you understand. See this. Just try to understand what this means. So time taken for the onward journey is more. So that one minus time taken for the return journey. This is only less. This difference is 5 by 2. And how do we find time? This is the equation. See if you can write this. You've understood everything. You can construct the equation easily and find the answer. This is what you'll have to write. This is what is very important. This one you should not write. The difference in time taken is 5 by 2. Time for onward minus time for return is equal to 5 by 2. And how do we find time? Distance by speed minus distance by speed is equal to 5 by 2. And what is distance? 150. What's the speed? Onward speed x, 150 by x. What's the distance? 150. What's the return speed? X plus 10. That's it. 150 by x minus 150 by x plus 10 is equal to 5 by 2. And this time, is it in hours? Yes, it is in hours. It shouldn't be in minutes because we have taken speed in kilometer per hour. So time should be in hours, and it is. You can write 2.5 also, or you can write 5 by 2. Let me show you the answer fully. You can write this here. Here, you can write time onward minus time return is equal to 2.5. Yeah, those who have not completed this, please write down the answer. Done, children?
Yes, ma'am.
Why this 150 by x here? Because distance by speed. Time is distance by speed. Time taken is equal to distance by speed. Two 2.5 is 25 by 10, which is 5 by 2. 5 by 2, when it comes this side, becomes 2 by 5. So x and minus x will get cancelled. Similar to one working we saw yesterday. X and minus x cancelled. So you have 150 into 10. 150 into 10. 5 by 2 becomes 2 by 5. And then this one, when you cross multiply, it goes up here to the other side. Very important, children. Please, x and minus x gets cancelled. 150 into 10. 150 into 10. 5 by 2, when transposed, becomes 2 by 5. And this one, cross multiplying, it goes up to the numerator on the other side. And on simplifying this, you get 600. So onward speed 20, return speed 30. Finished this yesterday. Didn't we, children? This one?
Yes, ma'am.
This also had given us homework, children. I just need 2 minutes. Let me just put you with another. Have we finished this one?
No, ma'am.
No, right? Okay. I'll just leave you with this question for some, less than 5 minutes. I'll just get back, children. Please try this one. We've understood
this yesterday, ma'am.
Yeah, okay. I don't remember the instruction I gave you. Okay, then I'll just put you with a different sum. 1 second. Yes, children, please try this one. We'll go back to that. We'll go back to that one, question number 4. Please try this one. Write down this question. Please try this. I'll just get back in some time. Thank you, children. So here the diagonal of a rectangular field is 60 meters more than the shorter side. So let's just write it using symbols. The diagonal of a rectangular field, see a diagonal, is 60 meters more than the shorter side. See, diagonal is 60 meters more than the short, more than something, right? So you cannot write d is equal to 60 plus. It's 60 more than something. More than some 60 more than something. What is that? Shorter side. Diagonal is 60 more than the shorter side. The longer side is 30 meters more than the shorter side. Find the size of the field. So basically rectangle. So this is the longer side, this is the shorter side, and this is the diagonal. You can also draw a rectangle like this, okay? You can also draw it like this and say this is the shorter side, this is the longer side. That doesn't matter. This is the shorter side, this is the longer side, so this is your diagonal. Whatever. Or you can draw it like this and say this is the longer side, this is the shorter side, and this is the diagonal. It's a rectangle. So you can connect the three sides, the longer side, the shorter side, the diagonal, all using Pythagoras theorem. Because the longer side, the shorter side, and the diagonal, they form the sides of a right triangle. It's a rectangle. This is 90. So you just have to assume, you just have to take some expressions for the longer side, shorter side, and diagonal and connect the expressions using Pythagoras theorem. That's all. That will give you the equation, solve, find the value of x, and hence find the longer, shorter, and the diagonal. Longer, shorter sides and the diagonal. Now tell me, children, who is x? Anybody can be x, okay? Anybody can be x. So see here, diagonal is 60 meters more than the shorter side. Longer side is 30 meters more than the shorter side. Who will call x, children?
Shorter side.
Anybody can be x. Shorter side is x is also fine. Anybody can be x. So if you call the shorter side as x, the diagonal is equal to x plus 60. Let the shorter side be x. The longer side is, shorter side is x plus 30. Implement this in the figure. Diagonal is x plus 60. Longer side is x plus 30. The shorter side is x. X plus 60 the whole square is equal to x plus 30 the whole square plus x squared. Because Pythagoras theorem. So you can also do this. Diagonal is equal to longer side is equal to. Children, you can even call the diagonal as x, children. You can even call the diagonal as x. If you call the diagonal as x is equal to shorter side plus 16. So the shorter side will be x minus 16. The shorter side is x minus 60. Supposing you call the diagonal as x, then you should find the shorter side in terms of x. You can take only one variable, one unknown. All the others you should find in terms of that unknown. If you take the diagonal as x, you must find the shorter side and the longer side in terms of x. If you take the shorter side as x, you must find the diagonal and the longer side in terms of x. Okay, so I'm saying if you say let the diagonal be x, then the shorter side will be, shorter side is here, shorter side is x minus 16. Then what is the longer side? Longer side will be, we know that this is x minus 60, right? This one is x minus 60 plus 30. So the longer side is equal to x minus 30. X minus 30 is the longer side. So rectangle, shorter side is x minus 60, longer side is x minus 30, and diagonal is x.
Ma'am, x is equal to 90, ma'am.
X is 90, is it? Okay, 1 minute. We are still trying to understand the assumption. 1 minute. So children, tell me the other way now. Let what, children? Let what? Who's x?
Let the shorter side.
No, that we already did, no? Shorter side x we already did.
Diagonal.
That also we finished.
Longer side.
Yeah. So tell me, Arnav, if the longer side is x,
The diagonal is x plus 30 and the shorter is x minus 30.
let the longer side be x. So x is equal to,
The longer side.
yeah,
30
yeah.
meter. Sorry.
Please complete this.
Longer.
X is, if longer side is x, x is equal to shorter side.
Then x minus 30 is shorter side.
No, let me just write this. So x is equal to shorter side plus 30. So the shorter side will be x minus 30, correct? And
Yes.
what do we do here? What is the shorter side?
X minus 30.
X minus 30 plus 60 is equal to the diagonal. So the diagonal is x plus 30. So if you take the longer side as x, the diagonal is x plus 30 and the shorter side is x minus 30. So you can assume anything to be x. Yeah, somebody said 90. 90 is what? 90 is the diagonal, is it?
Ma'am, 90 is the shortest side, ma'am.
Shorter side.
Shorter side.
Very good.
And longer side is 120, ma'am. And diagonal is 150, ma'am.
Very good. This is by Pythagoras theorem. So when you expand, we'll have to be careful, children. X plus 30 the whole square, a square, b 2ab b square, x plus 60 the whole square, a square 2ab b square. Okay. Please write down this. Have we finished this, children? I didn't ask you. Any questions here? Any doubts, children? Okay. What is the next question? Class, use the emoji. Raise your hand. Nishita, Anish and Shivani. Anish, are you there? Muttuvel. Okay, so Anish, Muttuvel, Shivani, Nishita, Priyadarshini, Nivedita, Akshay Ram, Hariharan, Tirunesh, Shabarigrish, Arnam, Balahari, Shruti, Nafi, Shakti, Lakshita, Manasa, Shreya, and Sudarshan. Since I shared the recording, people, take the liberty of not attending the class according to their convenience. Okay. All right, children, thank you. Let's see this one. A sailor can go 8 kilometers downstream. So these terms downstream, upstream, we have already seen in the chapter linear equations in two variables, which we had for term 1. A sailor can go 8 kilometers downstream and return to the original position. That means come back upstream. A sailor can go 8 kilometers downstream and return, meaning and travel 8 kilometers upstream in 1 hour 40 minutes. If the speed of the stream is 2 kilometers per hour, find the speed of the boat in still water. So 1 hour 40 minutes is the total time taken. It's not the difference in time taken. 1 hour 40 minutes is the total time taken. The time taken to go, the time taken, see, the time taken to go downstream plus the time taken to return upstream. The total time taken is 1 hour 40 minutes. 1 hour 40 minutes. So 1 hour 40 minutes is what? 1 hour is 60 minutes. 60 plus 40, 100 minutes. So you can write it as 100 by 60 hours. Children, 1 hour 40 minutes, children. So 1 hour is 60 minutes. 60 minutes and 40 minutes, 100 minutes. 100 minutes is 100 by 60 hours. So 0, 0, 5, sorry, 2 5s are 2 3s are. So it's 1, 2 by 3 hours. 1, 2 by 3 hours. So 1 hour 40 minutes is 100 by 60 hours. Now, how do you calculate the time downstream? Distance by speed. Time upstream, distance by speed. Total time taken is, what did we calculate? 0 gets cancelled, 5 by 3, which is 1, 2 by 3 hours. You can have it as 5 by 3 also. So what's the distance downstream? Distance downstream 8. Speed downstream. The speed of the stream is 2 kilometers per hour. So if the speed of the boat is boat plus water, boat minus water. Boat plus water is downstream. Boat minus water is upstream. The speed of the boat plus the speed of the water is the speed downstream. Speed of the boat we don't know, x. Speed of the water is 2. So x plus 2 kilometers per hour is the speed downstream. Upstream is rowing the boat in the direction opposite to that of the flowing water. When you row your boat in the same direction as the flowing water, water flows in this direction, and you're also sailing. You're sailing in your boat in the same direction. That is downstream. That is going downstream. Water flows in a particular direction. You're rowing your boat. You're also traveling in the same direction. You're rowing your boat in the same direction as the direction of the flowing water. That is downstream. So water is flowing at the rate of 2 kilometers per hour. You're rowing at the rate of x kilometers per hour. X plus 2, because you're going the same direction, no? Downstream, same direction. Your net speed will be x plus 2 kilometers per hour. Upstream meaning water is flowing in this direction, but you are rowing your boat in the opposite direction. You are trying to move at x kilometers per hour, but the water is opposing your speed at the rate of 2 kilometers per hour. So your net speed will be x minus 2. You are trying to go at x, but water is opposing your force, right? Your speed. So the net speed is x minus 2. Water flows in this direction. You row your boat in the same direction, downstream. So speed will be the speed of the boat plus the speed of the water. Upstream is water flows in a particular direction, but you are rowing your boat in the opposite direction. That is, upstream is not going up like this. You cannot row your boat like this. It's not upstream like this and downstream falling down like this. It's not that. So upstream is water flows in a particular direction and you row your boat in the opposite direction. So you're rowing your boat upstream. So you're trying to move at x kilometers per hour, but the water is opposing your speed at the rate of 2 kilometers per hour. So your net speed will be x minus 2. Is this correct, children?
Yes, ma'am.
So here, what is the equation in words? The time taken to go upstream plus the time taken to return downstream. The total time taken, you should add. It's not the difference in time taken, it's a total time taken. It's a total time taken. He can go 8 kilometers downstream and return, meaning 8 kilometers upstream. Return meaning 8 kilometers upstream. You go to Chennai and return. So if you're going 400 kilometers, you have to come back 400 kilometers. So 8 kilometers downstream and 8 kilometers upstream. The total time taken is 1 hour 40 minutes. So time is distance by speed. Distance is 8 in both the cases. Speed is, if the boat speed is x, if the speed of the boat is x, boat plus water, boat minus water, boat plus water is downstream. Boat minus water, speed of the boat minus the speed of the water, or stream. Stream is water, the current. We'll have to solve this and find the value of x. There's another way of converting, children. So 1 hour 40 minutes, you can also convert like this. It's a shortcut, that's all. I explained how it is 5 by 3. This is a shortcut. You can say 40 by 60. 1 hour, 40 minutes is 40 by 60 hours. 1 hour, 40 minutes is 40 by 60 hours. So gets cancelled. 2s are 3s are. So 1 2 by 3 or 5 by 3. But children, supposing it is 2 hours and 40 minutes, 2 40 by 60. You cannot cancel 2 and 60. You can simplify only within this fraction 40 by 60. So it is 240 by 60. Supposing 0 0, 2s are 3s are 2 2 by 3. It is 2 2 by 3. Read through the answer first from the slide. So the working is mostly similar. So see here we take out 8 common. 8 is common. The distance factor is common, no? 8. Bring it out, and 1 by x minus 2, 1 by x plus 2. LCM is x minus 2 into x plus 2. X minus 2 into x plus 2 is LCM. What is a minus b into a plus b? A square minus b square. That's what you see here. X minus 2 into x plus 2 is LCM, which is a square minus b square, x square minus 4. Then write this here, x plus 2, x minus 2. Is equal to 5 by 3. So here plus 2 minus 2 cancel, so you get 2x. 8 into 2x by x square minus 4 is equal to 5 by 3. Can you see this 8 into 2x? 16x. This is 16x. Next step would be 16x by 16x by x square minus 4 is equal to 5 by 3. 16x by x square minus 4 is equal to 5 by 3. Cross multiply. Sixteen x into 3 is equal to 5 into x square minus 4. Quadratic equation, solve and find the value of x. Negative, not possible. So x is 10. The speed of the boat in still water is 10 kilometers per hour. Understood, children?
Yes, ma'am.
Yes, ma'am.
What is rowing the boat downstream?
Adding.
No, what is it? What do we mean by that? When you're rowing your boat downstream, that means you are
Going by the direction of water.
yeah, you're rowing in the same, you're moving your boat in the same direction as the flowing water. What is going upstream?
Going
From
against
an
the flow
opposite
of water.
Correct. Against the speed of the water or in the opposite direction. So where is the net speed more, upstream or downstream?
I mean, downstream.
Downstream, because downstream what happens? You are moving, you're
Yeah.
trying to move your boat at a particular speed. Water is also helping you to move because you're moving the same direction. Water is already flowing at a particular speed. You are rowing your boat at a particular speed. So your net speed is more when it is downstream. Speed of the boat plus the speed of the water. But upstream, the speed of the water will oppose your speed. So it will reduce your speed. Upstream speed is less. Downstream speed is more. So you should add for downstream, subtract for upstream. Remember that it is the boat speed first, children. See, supposing, please listen to this carefully. Supposing you're given the speed of the boat is 10 kilometers per hour. Okay. This is very important. Listen to this carefully. You are given that in the question you're given. Okay, so let me correct it here. If the speed of the boat is 10 kilometers per hour, find the speed of the current. Speed of the current or stream or whatever you call it. Stream or water. So supposing this is the question, children. If the speed of the boat is 10 kilometers per hour, speed of the boat is given. Boat is 10 kilometers per hour. Find the speed of the current. So what will be the speed downstream? Or what do we say? Let speed of stream be what, children? Let the speed of the stream be what? Let the speed of the stream be what happened, children? Am I not audible? My question is not clear, children.
Yes, ma'am. I didn't understand that question. Can you repeat?
No. I'm saying I've changed the information in the question. Is that visible?
Yes, ma'am.
Okay.
Yes, ma'am.
Now here, what do we? Yeah, what should we assume here? We are given the speed of the boat, right?
Yes, ma'am.
So we have to assume the speed of the stream.
10 minus x.
No,
10 for downstream,
no.
10 plus.
No, I'm not asking downstream, upstream. What is the speed of the stream?
X kilometer.
X. Yeah, let the speed of the stream be x kilometers per hour. What will be the speed downstream?
10 plus x.
What will be the speed upstream?
10 minus
10
x.
minus.
Yeah, be careful. Here is what now you're both of you are right. This is where we have to be careful. 10 plus x, x plus 10 is fine. But 10 minus x and x minus fine. Sorry, 10 minus x and x minus 10 are not the same. So remember to write the boat speed first. Speed of the boat plus the speed of the water. Speed of the boat minus the speed of the water. You cannot write x minus 10. It's not the speed of the stream minus the speed of the boat. To the speed of the boat, you add the speed of the water. From the speed of the boat, you subtract the speed of the water. Remember this. Boat plus water, boat minus water. Boat is 10. Water is x, 10 plus x. Boat is 10, water is x, 10 minus x. It's the speed of the boat that has to be written first. And then we need to add or subtract the speed of the water or the stream or current. Be careful there. All right, children. So please complete this answer. I don't know if you finished it. Take a screenshot. If you have not completed, please take a screenshot. Complete this answer. All right, children. So that's it for today's session. Thank you so much. Good night.
Thank
Thank you, ma'am.
Thank you, ma'am.
Thank you, children. Good night, children.